For year 11 methods, we're going to look at exercise 13c, question 3 and 4. So we're trying to plot um, both these graphs on a CAS calculator, and we're trying to work out these values. Okay, so what this basically means is, when y equals 14, find the value of x, and find the value of y equals 6. Okay, so you'll be able to use xcal, ycal for that. So what's the difference between the two graphs? So for part 3, or question 3, we know this is base 2 to power x. So 2 to power x will increase slower compared to base 10 to power x. So if this is 2 to power x, this other graph would be 10 to power x, because 10 to power x would be increasing faster. It looks something like this. Okay, they both have an asymptote at y equals 0. So this will be 10 to the power x. And we're just trying to find where, for the first graph, for the red graph, when it equals 14. Okay, when the graph equals 14. So if I draw the line y equals 14, we can find the intersection point. Okay, so if this is 14, y equals 14, we're going to find the intersection point. So I'm going to use the CAS calculator. So let's go and use the CAS calculator. I'm going to clear all, because it does say you are meant to use the CAS for this. So let's graph this graph. Okay, so I'm just going to cheat and just go to the power x, drag and drop. Okay, and what I'll do is I'll also zoom out a bit and type in 14. So y equals 14. So remember, when you using drag and drop, you don't need to put in 14. You're just trying to find intersection point. Analysis gsolve intersect, and that they intersect at 3.81, 14. Okay, so the intersection point will be here, 3.81 and 14. Okay. Another way you can do it is by solving on the main menu. Okay, so you're trying to find 2 of x equals to 14. Interactive and solve for x, that'll work as well. You'll get exact answer, but if you want decimal, then you'll get the same answer. So 3.81, 14. Okay. Now, for the other one, 10x equals 6, you can do this on the CAS. Go 10x, 10 to the power x equals 6. You can solve it, interactive event solve, and you get 0.78. Or obviously you can do it graphically. Okay, so I'm going to delete this. Edit clear all. You can literally go this and this, graph both of them on the same graph, and then go interactive analysis gsolve intersect. Get the same answer. So hopefully that gives you an idea of how to do question 3 and 4. Now, for question 3c from exercise 13d, let's go over this. Remember, these aren't prime numbers, because we've got to break these down to prime numbers. 27 is 3 to the power 3 times 3 to the power x equals 3 to the power 3x times 3 to the power half. Okay, now they're all to the base 3, you can combine them. So this is 3 plus x on the power 2, that's 3 to the 3x plus a half. Now I'm going to multiply this by 2, because that whole thing's a power. So that's 6 plus 2x equals 3x plus a half. Now, because these bases are the same, I can compare the powers, they're the same. So I can equate the powers. So 6 plus 2x equals 3x plus a half. I'm going to subtract x from both sides. So 6 equals x plus a half. So x must equal 6 minus half, which is 5.5. Okay, or 11 on 2. So that's basically how you do 3c from exercise 13c or 13d. So hopefully it helps.